We have Chris Truncer next. He's coming in. I know Chris's work. I haven't met you, Chris, before, but I know your work. I was just telling him over chat that I am a huge fan of Eyewitness. Been using it forever.
Oh, thanks.
Yeah, I just the 2 to 3 transition with losing RDP. I saw that and I was like, well, okay, whatever. But other than that, I mean, I'm a fan. I've put it in classes. I've promoted it. So thank you for that. But this is not on Eyewitness, right? So this is on
Nope.
an actual C2 thing. And, having launched the cloud pen testing course, I will tell you, people are all about cloud. So by all means, I'm glad to introduce you to this talk. Chris Truncer, he is the co-founder and the security lead, offensive security lead for 40 North, right? Am I saying that right?
Yep. Yeah. Perfect. You
There
got
you
it.
go. And you should have, you should be able to go forward and back.
Let's see.
Can you? Yeah,
Yep. Looks like I can. Hey,
that's you. There you
I'm
go.
doing it.
Yeah.
All right. Well, I'll go ahead and get started. Thank you for the introduction. As you said, my name is Chris Truncer. I am here to talk about, the talk title is called Building Fully Functional C2 with Azure. And hopefully we're going to look at a cool different way that we can use Azure to accomplish a task of our normal C2 methodology that we follow from an attacker's perspective, or helping to teach our blue team brethren and sisters about different options that you can see, like what different attackers are using out there to accomplish C2, so that you guys can hunt for it and look for it. The least important slide out of this whole slide deck, just my background, who I am. My name, like mentioned, is Chris Truncer. I am a co-founder of the security company 40 North Security, based out of Colorado. I say I'm our offensive security lead. I'm basically just trying to come up with a title that worked and fit. And I like to write a lot of different code. Notice I did not say like to write great code. I like to write code that I hope works at times. A couple different projects that I worked on are like Veil, Eyewitness, Swimming Implant, just to name a few. But that's really who I am, my background. I started as a systems administrator before I moved into security, and have just been in security ever since. So what's this talk about? Well, we're specifically going to be looking at Azure and talking about Azure, different options that it provides to us from an attacker's perspective. And we're going to dive into a couple different pieces of its functionality specifically. We are also going to look at, we're going to discuss the concept of a redirector, which maybe most people know about, maybe not, which I almost hope not, so that we can help introduce some new topics. And then we'll look at a different way to build out a redirector using Azure services that they have available. All right, so let's get started. Let's talk about Microsoft Azure. I am a fan of Microsoft Azure myself. I personally find it a lot easier to use than Amazon's AWS cloud. With that said, they're basically the same thing. Azure is Microsoft's cloud service offering. It's obviously a competitor to Amazon's AWS, right? But really, they both have all the same types of services out there. Like, they can do a whole bunch of different things. What one has at Azure, you can do within AWS. So what I'm going to talk about today is also easily done and reproduced in an AWS environment as well. So what sort of functionality do we typically associate with Azure, or really any cloud provider, right? Well, the main one, hopefully, or the main two, is going to be really the always-on capability and high availability, right? Now, of course, we learned that that's not the case when Northern Virginia gets hit with massive storms and Amazon's East environment goes down. But that's pretty rare, right? For the most part, what we associate with cloud capability, besides it being someone else's computer, is that it's always on and available. We shouldn't really have to worry about our stuff going down, our services, or whatever it is that we're using going down. And that's really important, obviously from a general IT computing perspective, but also from an attacker's perspective. I don't want my stuff going down. if I'm compromising my customers and their environment, like that's going to give me heartburn. It's like nightmare if all of a sudden the server that I'm using just decides to like crash and reboot and like doesn't start back up. That is a really bad feeling. So we like to leverage the cloud for part of our C2 methodology. So of this functionality within the cloud, like what else is there, right? Well, most of the time when I think of the cloud, or at least originally thought about using different cloud resources, I generally thought of like computational resources, right? Like cloud computing, maybe some GPU usage, as we also learned about how GPUs can be provided or can be used to help build out different models in the previous talk. We can use that for like hash cracking or anything else that we want to use a GPU for if we don't have it on site or the ability to use it on site. But right now, that's all I'm kind of talking about, right? Just like basic computing. Well, there's a whole lot more that goes beyond just this. Like there's more out here to just virtual machines where we can see CPU usage, in this case, network usage, how much disk usage that's in here. Like there's a lot more to it than just this. Like we aren't stuck with using only standing up like different virtual machines or like a virtual private server in a cloud, because there's a lot more that we can use both within Azure and within AWS as well. Even like Google Cloud, like there's really any of these other cloud providers allow us to do multiple different or accomplish and solve multiple problems with different services. So again, going back to this is really probably the first capability most people, at least myself, associate with cloud service offerings. It generally will be a core service offering of each provider, but there's a lot more that these different cloud providers can provide as well. Storage is obviously one. You can have, like, we all have heard about like block storage or like just different storage environments that have been left exposed to the internet without any security, that's like without any like vetting of authentication prior to accessing the data that's stored within it. Like almost once a month, it seems like you're going to hear of some sort of like breach of data that has been stored within a cloud storage environment that should have been locked down but wasn't. So that obviously is a service offering that we can offload data storage and not necessarily just computing. Another one, which attackers and offensive security practitioners have really started diving into within the last few years, is the concept of using it as a CDN, or primarily for probably the services or the capability of domain fronting. But before we get into that, how do we use different CDNs and where can we access them? Well, Azure can provide you with access to multiple CDNs, actually. So Microsoft runs their own CDN. They also have access to Verizon's CDN, which you can use to help distribute content or whatever it is you want to do legitimately. And there also is Akamai. And so, random funny story, I had always thought and personally believed that Akamai was really hard to get access to that CDN. And I consistently, when I was first trying to understand like how to use it, was looking up different providers out there that basically offer Akamai access so that we can distribute content through it. And a lot of them always seem to want to offer it, but for a pretty expensive rate. And so eventually we found out that within Azure, you can actually deploy straight into Akamai CDN, which is awesome. My concern was I was going to be using it for offensive security purposes for a test. And I just had no idea where I was going to hit coming back on like, what's the price going to be for this usage? I was expecting a heavy bill, but I was willing to test it out for a month just to see what sort of pricing it may cost. So we did end up using Akamai through Microsoft Azure. We were able to establish command and control through it, and Akamai allowed us to domain front through it. And at the end of the month, I think when it came out to the bill, it was probably 11 cents. So long story short, you can leverage legitimate CDNs, Akamai, Verizon, any CDN, really for a pretty cheap price through different cloud providers. So like I mentioned, Azure was probably one of the easiest places to get access to Akamai. And I wanted to use it for domain fronting. So why do we care about it? Again, domain fronting. Let's talk about that and how it works. Here is my basically, if I'm a Visio noob, this is the next closest thing that I can have to try to building out any form of basic attack flow. So I apologize for what probably looks like a third grader built this diagram. All right, but let's talk about this. So in your standard setup, we have, hopefully you guys can see my mouse moving. We have a victim PC at the very top. And so these different paths through the firewall down to the team server shows multiple different options that the victim PC could be connecting back to our team server. And the way that it's going to choose is going to depend upon the configuration and like how it was compromised, right? So it's going to show or it's going to follow whichever path based off of like how, when it was compromised, is configured to do so. So when we have like talked about normal C2 tradecraft, usually we have something like this redirector in this like middle row, right? So like here we have a redirector on the left, domain front in the middle, redirector on the right. The reason we do this is because we never want to have our victim PC ever directly talking to our team server. It's for multiple reasons. One, because I want to try to hide my true team server location from any incident responders or blue team that are trying to catch what I'm doing. Excuse me. But additionally, from my perspective, from a offensive security practitioner, if I have a team server that is directly talking to the victim PC and it gets blocked, then that means I have to stand up another team server, right? Well, if let's say I have to stand up 5 different team servers throughout the course of an assessment, at the end of it, if I'm trying to aggregate logs, reporting to see everything that it is that I did so I can provide that to my customer, I'm now having to do that across 5 different places and basically aggregate everything together and make sure timelines match up. Well, why not just have one single point of like service and have it where I only connect to my team server and I just protect that, and so that all of my data just resides in one place. So there's obviously more to it than just that, but that's the reason why we will have some of these different paths. So like I mentioned, these redirectors are here, which act to redirect traffic so that as the victim PC goes out the firewall, it doesn't actually go directly to my team server. It goes to my redirector, let's say over here on the left. That redirector then will, through one means or another, forward that traffic on from it to the team server. The team server, which is where my command and control server is, will respond with, let's say I wanted to take a screenshot. It will send that command back to the redirector, which will then forward that command back to that victim PC. So the redirector is basically a good, almost, man in the middle, where it's just forwarding traffic on from the victim to the team server and back, preventing that direct connection. Well, there's an issue with this, though, right? From an offensive security standpoint, if I'm being investigated and an incident response team finds the domain, hopefully we're using a domain, or the IP address of the redirector that's redirecting our traffic, all they need to do is potentially just sinkhole that domain, and that's going to kill the effectiveness of that redirector. At that point, it's no longer usable by me. So what if I want to have a different way that we can sneak traffic out? Well, that's where the whole concept of domain fronting comes in, where we can leverage a CDN to sneak our traffic out using a high reputation domain that goes to the same CDN we want to use. And once the traffic hits the CDN, rather than going to the legitimate server where it's supposed to go, we want to direct it over to our server, which is the malicious one where our team server is. And we can accomplish that with a CDN through the concept of domain fronting. I have another graphic we'll look at here in a second. But long story short, domain fronting allows us to use a highly reputable domains to hide our C2 traffic. So the way that it works is that victim system is going to look like it's actually making a request to maybe a subdomain of CNN.com or Microsoft.com or some other domain that leverages the CDN that we are using. The main key difference here is the host header in that request. If the host header points to the real destination within the CDN, then it can go to, that is how the CDN knows where to route it to, right? So the CDN will read that host header on the incoming request and route that traffic to the actual endpoint that it's supposed to send it to. Now, if we can just use the same CDN again as a high reputation domain, or excuse me, reuse the CDN with a high reputation domain, then all we need to do is modify that request so that the host header doesn't go to ajax.microsoft.com and doesn't point to their legitimate endpoint. The request still says ajax.microsoft.com, but now it's actually going to our malicious host also, or endpoint also hosted within the CDN. So the nice part about using domain fronting and a CDN within or for C2 is it completely eliminates the need for a redirector, because we don't have to have like an actual system that's up doing that. We don't need a virtual machine with IP table rules, or with using like an Apache smart redirector with mod rewrite rules. We can just use the CDN like it's supposed to be used and actually get our content coming to us. So here's another example. In this case, there is an actual domain, I believe it's CNN Tech Live, which is domain frontable through CloudFront, where the domain is actually cnntechlive.cnn.com. And so the way that this works is the victim system will make a request, which will go to CloudFront, right? CloudFront will receive that request. And what it's going to do at this point is it's going to look at what is the host header set to in that web request. If it is set to CNN Tech Live, and again, this is just making this up to make it easier, but if the host header is cnntechlive.cloudfront.net, then that is where it's going to direct that traffic to within the CloudFront CDN, and then that server will send a response back. However, if we can write malware that still points to this CNN Tech Live domain, however, we modify the host header in that request to, in this case, be attacker endpoint.cloudfront.net, we're still going to use CNN Tech Live to get as our primary web request. And then once it hits the CloudFront CDN, we're now actually going to our malicious endpoint that we control versus the real endpoint that's expected. And that is how we can sneak command and control traffic into and out of an environment using a highly reputable domain. So domain fronting takeaways, like these really give you the ability, again, use highly reputable domains for C2. Like you can legitimately use a Microsoft domain for C2 traffic. How many people are blocking a subdomain of Microsoft leaving their environment? Probably not many. It does eliminate the need for a redirector system. The nice thing is you can go as far as to even build in rules to help filter incoming web requests. So you can try to prevent specific user agents. Like you can really be as flexible and as complex as you want to filter out and make it a smart domain front redirector, if you will. The nice thing is this is not a single server or a system that can go down and break any or all of the C2 between you and your system. So this is not a single point of failure where if your redirector or virtual machine reboots or goes down, then you're hosed temporarily. You're using an entire CDN. So you're basically going to have, like all of Akamai is going to have to go down. All of Verizon's CDN, all of Microsoft's CDN would have to go down for you to do those. So you're almost building a little bit of resiliency into your C2 infrastructure. So with all of that said, this is where we really started kind of taking over and wanting to look into, is there any other cloud functionality that can provide the same capabilities as a virtual machine or as a CDN? Like, is there something else that we can use that can help get a web request to a location that we want it to go? And the answer is there's this awesome concept within Azure called Azure Functions. And so this is what we started exploring. So what are Azure Functions? Well, you can think of it as serverless code. This is basically Azure's version of an AWS Lambda. So an AWS Lambda within Amazon's environment is the exact same thing as an Azure function. In my opinion, personally, it's a lot easier to get up and running with an Azure function. It's way easier to get that going to do what I'm about to show than it is with an AWS Lambda. But I believe the guys from MDSec also actually did write up a blog post about using AWS Lambdas as a redirector as well. So if you want to check out how to do that with AWS, go check out their blog post. Like that's definitely, it has a lot of this functionality documented that'll help get you set up. So an Azure function is basically an event-driven function which does something, right? So when an event happens, such as an incoming web request, the code is triggered. The nice thing about functions is they support a wide range of languages for you to develop in and to write your code in. So you can write it in C#. You can write code in Python, which is what we do for this demonstration. You can use PowerShell, Node, JavaScript, PHP, and so forth. So long story short, like they try to help basically sell you, like, why do you need to deploy an entire virtual machine when all that virtual machine is going to do is like run 25 lines of Python code, right? Or maybe it just like is an IP table redirector. So like if that's all it's doing, like you don't need a full virtual machine for that, do you? You can use something like an Azure function to accomplish the same thing. So all we need to do is write the code which conducts any action that we need it to perform, select a trigger, which is what invokes our function or code to run. And then once we've done both of those, we can just deploy our function code into Azure. And if anyone uses VS Code, which is free text editor from Microsoft, VS Code makes it incredibly easy to deploy an Azure function into Azure. And when we do a demo, you'll actually see me do it. And then the way that this works is anytime your trigger hits, whether that is an incoming web request, whether that is like a scheduled task, your function code will run. It will trigger it to run. So let's look into this. So again, here is VS Code. If you guys look into the extensions that are available within VS Code, one of the extensions available is Azure Functions. If you have any interest in doing this at all, I highly, highly, highly recommend that you guys install this function. This has made my life so incredibly easy. I promise you it will do the same for you as well. This is what you can use to help set up a function. It will like build out all the necessary files that you need in order for it to exist and run within Azure. You can add your code and edit it through VS Code. And then this Azure function will allow you to, with one click, push your code to Azure and get it all deployed. So let's talk about what are the different triggers that are available that we can use. So there are multiple triggers that you can choose when building an Azure function. These aren't all of them. This is not all inclusive, but these are the main ones. So some of the main functions out there are like timers, right? So you can almost think of this as a scheduled task. So this is maybe something that executes every hour, every 30 minutes, every minute. The world is your canvas. Like, go with whatever you want for your creativity. You can have it schedule and execute as often as you want. Blob storage is another option that can be a trigger. You can have it trigger your code when like blob files are modified. The other one, which is the more interesting one to me though, is the HTTP trigger option. In my case, this is the easiest for me to work with. The way that this works with is when a web request is made to a specific URL, it's going to invoke your code. Easy as that. So if I wanted to start creating in a function within VS Code, basically after I install the VS Code add-on, what I'm going to do is like click on one of these buttons to start telling it to create me a new function. And during the process of creating a function, it's going to ask, what trigger do you want to use? And so in this case, I'm selecting an HTTP trigger. As you can see, there are many more options here, and there might even be more now. But one of the first one that I care about, or the one that I care about, is this first one, the HTTP trigger. So what if I don't want to do it through VS Code? How do I start creating a function within Azure? Well, all you need to do is, if you're in the Azure portal, you would click on all services. You would click specifically in the compute section, and you will see an option for a function app right here. And so you would click on this, and that is how you can start building out and creating your function. Once you've clicked on that, all you would do is click on the plus add button over here, and that would, again, start walking you through what you need to create. The different information is going to prompt you and ask you to create a function. So here's where it starts to get pretty cool. So this is some of the information that it'll ask. You're going to have to go through some of the standard stuff. So like if you guys have used Azure before, you know that you're going to have to create a resource group, right? And that's like a logical grouping of related cloud resources. So for example, if I'm having to stand up like multiple cloud services for testing Google, let's say, I can create a resource group called like Google Test, and then throw all of my resources in here. So like as I create a resource, it's gonna ask me what resource group do you want to put it in. And so in this case, I would call it like, I would select a Google Test or create a new one if I didn't have one. That way, so it's when I am done with my test, I can go just look at that resource group, and I can see everything that I created is all contained within that resource group. And it makes it super easy to figure out, okay, I can probably like get rid of all of these now, right? I don't need them anymore. So same concept here when we're creating our Azure function. We're going to assign it to a resource group. The coolest part here is we're going to give it a function name. So you provide whatever name you want to use. But if you look here, it's this function name, and then it's a .azurewebsites.net. We'll talk about that in a second. Next up, it's going to ask you, like, what do you want to actually publish? Do you want to publish code or Docker container? In this case, I'm selecting code, and I'm telling it that I want to publish Python code. And so again, here's where you can select different languages of what you might want to write your Azure function code in to use. So in this case, again, selected Python, specifically version 3.7, and I'm deploying to the West US2 region. You can obviously customize this to be whatever you want. If you want to write .NET or C#, like go for it, Node, any language that you want to, that you're more comfortable with, I would highly recommend exploring and playing with it and using that. And all you would do to change that is just right here within this Azure portal. You just tell it what code you want it to run. So the coolest thing about this, though, is you remember how I said you have to provide a function app name? Well, that is going to be actually used to help trigger your web request. So you get to basically use the Azure websites.net domain for C2. What will happen is you just specify like whatever that name is, in this case, 40 North Security, but it could be Microsoft CDN. It can be something incredibly generic. It can also be something incredibly specific to your customer. What it will do is it's going to validate to make sure that that subdomain doesn't exist. And as long as it doesn't exist, that's what you're using for C2. So that's awesome. I love that I can still use like a highly reputable domain like Azure websites.net and just have a subdomain of that for C2. So that's awesome. Look into it. Anyways, once we hit create at this point, we can now work on building out our Azure function code. So again, I've been talking about this fairly high level, fairly abstract, but let's actually look at some code here in just a second, and we'll see what we are doing. So in our case, like I said, I like Python. We chose to just use Python because most people seem to be able to understand it or play with it at some point. So let's look at it. Again, in this case, here's where we're selecting that subdomain that we're using, and the languages is down here. One thing to note, though, before we actually do look at the code, is you will be setting the subdomain for your function, but Azure will also give you the URI for the function name. So with that said, you're likely going to have to develop your function code first. So this is going to be a little bit specific to Cobalt Strike, but really, this is also specific to any C2 option out there that lets you specify like domain URIs that it's going to use for C2. If I want to use an Azure function, the first step I'm going to do is build out my function first, and then I'm going to look to modify and create my malleable C2 profile or wherever that I customize how my agent connects out to me. So if I'm doing this, one thing that's also worth mentioning is and we're going to see why here in just a second, when I talk about Azure functions, you have really kind of two different tiers of functions. You have like your parent function, which is the overall Azure function itself, which has like control of everything underneath it. And then you have what may be sub functions. And so I think of like a sub function as in relation to C2. So for example, when I'm doing basic C2, I probably want to have at least 2, if not 4 different requests that I've customized, right? That can be a GET request, a POST request, and then maybe 2 different requests for like the staging process if I do stage, depending upon the architecture. Otherwise, at a minimum, I'm going to want at least a function for GET requests and a sub function for POST requests. Those will allow me to separate or like basically build out that functionality and support most agents, because most C2 agents are going to make GET requests out to get tasking. And if they need to send data back, like if you took a screenshot and they need to send that back to you, that's probably sent in a POST request. Well, for Azure Functions, in order to support that, the easiest thing that really I'm going to use for that is to have a separate function for GET requests, a separate sub function for GET requests, and a separate sub function for POST requests. When we're doing that, the next thing we have to think of, and again, this is a little specific to the agent that you are using, is how does your C2 tool uniquely identify each agent? Well, in the case of Cobalt Strike, you can have that unique identifier be present in a server header, right? So if that's how we are actually uniquely identifying beacons in the request, we need to make sure if we are building out like a redirector within our function code that we capture those headers. Otherwise, our team server, without having those captured, is not going to know like what beacon does this incoming request correlate with. So let's look at this. So here is a basic GET functionality right now. We can see that what I'm doing is I'm telling this to ignore any SSL issues. Don't do this in production. This is more for point of or proof of concept. What I'm doing is right here is I'm defining the URL that I'm going to forward an incoming request into. So so this code is triggered when an incoming request hits the URL that triggers this code, because again, we're using an HTTP trigger. So what's happening? So again, imagine that this code is triggered. We're telling it to ignore SSL issues. We're going to create a dictionary which contains the headers and the incoming web request. We are saying this is where we want to forward a GET request to. And then the first thing we're going to do is capture all headers in the incoming request and store it within this dictionary. Once we've done that, we're going to go ahead and make a new GET request from our Azure function to the true location of our team server, which we defined up here, and forward all of the headers that came in along with that request. Once we make that request, we're going to receive the response, and we're going to return that back from the function. So all this is doing right now is just a very basic redirector. It takes an incoming GET request, captures headers, sends them to the team server, receives the response back, and sends that response back to the originating system. Same concept here, except with a POST request, right? We're still monkey patching SSL up here. We are now, again, specifying a different URL for where the POST request is going to, but we're still capturing all of our headers. Now we're also capturing the body of the incoming POST request, and we're building out a request to the team server. We're including all the data in that POST request and including all of the server headers that were within that POST request. We're then forwarding and posting that to the team server, receiving the response back from the team server, and then sending it back to the originating system. Here's a very basic example of just like a staging process. Like in this case, we don't necessarily care about server headers, right? Because there's not going to be an identifying system or an identifier within those headers. So all we do are basically taking the incoming request right now and forwarding it on to the URL that our redirector is, or excuse me, that the team server is staging stuff from. And then we are returning that response back to the originating system. So long story short, I'll be able to answer anything about the code specifically, probably in the hallway or at the end of this talk, because I think I'm running a little close on time. But it's really at a bare minimum, as you guys can see, like 10 lines of code is all you really need to have in order to create a very basic redirector within an Azure function. So one thing to note, though, is when we were writing a function, there's metadata associated with that function. One of the metadata is like, how can we actually trigger that function, right? Well, like we said, we're going to use an HTTP trigger. Well, with that said, some functions can require some form of authentication still. The way that works is you can think of it almost as providing an API key with your web request to actually allow that function in your code to run. There's a couple different ways that you can configure your Azure function code to work. One is to require a functional key. So remember how we talked about one overarching function and your sub functions within it, so like your get sub function, your post sub function. Well, you can have basically an API key at the individual sub function level. So one for your get request, one for your post request. Those would have to be included within the request to the Azure function. Otherwise, the code just won't trigger. You also have a master key, which is basically an API key for that parent, that overall higher level function. If that is passed in and included, then it will work for all sub functions. So that's basically your master key, if you will. The other option, though, and this may be more of what you want, is to allow anonymous access. And that's exactly what it sounds like. It does not require a key at all in order to use it. You just hit it with a basic web request and the code is triggered. So that is what we are doing in this case. As you can see right here, one of the files that are required within an Azure function is a function.json file. And I'm specifying the auth level in this case to be anonymous. And that is allowing that code to run anytime someone accesses it. If you wanted to create a functional level, like a sub-function level API key, you would do it within here from the portal, the Azure portal. As we can see in this case, I'm looking in the get sub-function, but I have like a get sub-function, a post sub-function, a test web trigger sub-function. Specifically within the manage section of whatever sub-function you're interested in, you can ask for a new function key, and it will provide you with a key that you can use to authenticate and allow the incoming request to trigger your sub-function. Like I mentioned earlier, use Visual Studio Code. It's going to make life so easy. If you're doing all of your coding for Azure Functions within Visual Studio Code, like I mentioned, all you need to do is install the Functions add-in and authenticate into Azure through code. And then once you've updated the code to do whatever you want to do, VS Code will automate pushing and deploying everything to Azure and just make life so easy on you that you don't have to worry about packaging stuff up and like uploading it in whatever format that Azure needs. One thing to note is when you do post or like push your code to Azure, after it is done deploying everything into Azure, it's going to, at the very end, give you the trigger URLs that you use to trigger each sub-function. So in this case, the get sub-function, it will be triggered if I make a web request to this URL, post with this one, and so forth. For however many sub-functions you have, it will give you the web triggers that you would use in order to make that code run. Here we can see and just basically verify that the URL that we are using is just the webdeliveryonline.azurewebsites.net. This is where you would go if you just wanted to see, like, again, not through VS Code, but actually through the Azure Portal. Like, how do you verify like the location and how we get each website, or excuse me, sub-function to run? You can find all this information through the portal as well. I just personally find it a lot easier to use VS Code. The big thing to note is once you have your Azure functions ready to go is that your malleable profile matches the URIs needed to trigger your function. So make sure that the metadata, in this case for Cobalt Strike, is stored within a location that's accessible by your Azure function. In this case, we're doing it all in the headers because headers are very easy to access. So for example, our get function, we already know the domain, I think was like fortinorsecurity.azurewebsites.net. Well, the URL to trigger it was /API/get. So in my HTTP get code block, I need to specify that URI right here. Additionally, I'm ensuring that the unique identifiers for my beacon is stored in a header, which is accessible by my code, or by my function code, so that it can forward that information on to the team server. Same concept with HTTP post, same concept with HTTP stager. Like we are just making sure that everything matches up within our malleable profile code along with our Azure function code, what will trigger them. Here, oh yeah, so here it is with the HTTP post code block, showing the same thing, that our code basically just matches up with what our trigger URLs are. Finally, if I'm going to set up a listener then at this point within Cobalt Strike, all I'm specifying is the host, which is the function name that we gave it. So instead of fortinorsecurity.azurewebsites.net, I, in this case, gave my function application the name web delivery online, something very generic. And so all I'm setting for the host and the domain that my beacon needs to connect to is just webdeliveryonline.azurewebsites.net. So let's do a quick demo on what this looks like. I'm going to have to probably speak to this fairly quickly, so I won't be able to pause this. So I apologize if you guys can hear me talk quickly. I just want to make sure to give you guys as much information as I can as possible during this. So let's get started. So you can see right here, I have my standard Azure, basically the same exact code that we were looking at. This is a Git code, so we are just specifying here the URL that I need to go to for my team server for a GET request. Again, remember, that matches the HTTP GET of my malleable profile. I'm here capturing the headers, and now I'm building out the web request to go to that URL along with all of the headers that it received on the incoming request and forwarding it right here to my team server where I can see my HTTP GET code block section does match up with that expected URI. Same concept here with the post section. I now have the location where my team server is at. I'm still capturing all the incoming headers that are being sent in that web request. The post, as we're going to see, does match up the URI with my HTTP post section for my malleable profile. The big difference here is obviously I'm just capturing the data sent in the post request. And now I'm building out the web request, which will go to that URL of my team server, include all the data from the post request along with the incoming headers, and send the response back. Here in this case, I am having a staging URL. I am, in this case, capturing the server headers, but I technically don't need that because it's not included in the staging process. But that's just what this is doing, so it's not a problem. And again, we're just forwarding that request, the incoming request on, and receiving the response from the team server and sending it back out to the originating system. So now that I have my code exactly how I like it, let's go ahead and deploy this into Azure. All I need to do is click this nice fancy button at the top and say deploy to Azure into this specific function. And now this is what it's going to look like. It's going to ask me if I want to go ahead and deploy into Azure, and I'm going to tell it yes. And so VS Code is going to start the awesome process of like packaging it into into the format that Azure expects, and will handle like automating and deploying all of this for me. So what we're doing right now is proving that there aren't any beacons that are currently coming in. I'm going to go ahead and just build a PowerShell one-liner, I believe, yes, that will leverage that Azure function for C2. So I'm going to go ahead and have it configured to connect back to my listener. And now I'm going to go ahead and get to that file so I can copy and paste it and run it on a Windows system that I have. So there's that giant PowerShell one-liner that you guys can see. Again, this is just straight stock out of the box from Cobalt Strike. This is just more of a proof of concept just to show that it works. We're not doing any obfuscation at this point. So what I'm going to do is go ahead and run this. So I'm going to paste it in here in just a second. I think I also pull up Task Manager. Yes, just to show that like we don't have PowerShell running. There's not another beacon that's currently on the system that we're just hiding. So go ahead and paste it. And before I run it, though, I believe we're going to check and make sure that our Azure function code did deploy. And there we go. We can see at the bottom, we can see the trigger URLs, which means that it is deployed into Azure and that it is available for us. So now all I'm going to do is basically just hit start or hit enter, and it will run my code in the command prompt. So once we go back to the Windows system. I think the only other thing that I wanted to show is in this case, I did specify a different route prefix. So what that means is, as you see here, it's not /API. In this case, it's /40 north. There's currently a bug in Visual Studio, in Azure Functions for Python projects, which allows you to not use a standard, that API within the URI. We can talk about that in just a second, though. Long story short, we can see here, I ran it, my PowerShell code, and I did actually indeed go ahead and get my callback. And so I have everything now. So this did work using an Azure function for C2. So one thing to note, like I mentioned, is there is a small bug within the HTTP trigger URLs. If you guys remember, all the trigger URLs said /API. Well, that is what it is by default. One thing I would recommend is to customize it so it doesn't say /API, which we just did in that demo to use 40 North instead. However, the Visual Studio Code will actually display /API, even though you're using /40 North. So I do have an active bug in with them right now. So hopefully this will be fixed shortly. And again, this is just where I'm showing that even though I set it to be not API, it does show as API. So there's an active bug and it is going to be fixed. But you can verify that the real URI exists if you go into the Azure Portal, because now we can see the Azure Portal does show the correct one. So final thoughts. I think I kept you guys a little late, so I apologize. I'm going to try to wrap this up. Azure Functions are a super fast way to get set up and operational for a new redirector. Again, they're the equivalents of AWS Lambdas, but you can do a lot with it, right? Like it can be a dumb redirector, which is largely what we just had it do, or you can add a lot of logic into it and like have it filter incoming requests. Make sure it only matches specific conditions that you want before it forwards onto your team server. Otherwise, just forward it on to like Google or someplace else. Modifications to your functions are incredibly easy to do. They are pushed to Azure with a single push of a button. Give it a try. Like Azure Functions are really cool and can help make life easy for you. And you don't have to manage full-on infrastructure. All you do is write 10 lines of code and it can do what you want. So that's it. I don't know if I have time for questions right now. I'll let anyone else let me know if we do. Otherwise, I will be in the hallway channel so I can help answer any questions there. If you guys wanted to look at sample Azure function code, go to this GitHub repo. That code that you just saw in the demo and throughout this talk is available right there. So you can use that as just like a basis for an Azure function for a redirector, and play with it and add on additional functionality, make it way better than what it is right now. But we wanted to make sure to at least give you guys some form of code that you can start with so you have something that you can use. Otherwise, thank you all so much for your time. Hopefully this was an interesting talk, and I'm happy to help answer any questions now or on Slack or anytime in the future. Just reach out. Thank you guys so much.